Thank you for the kind introduction. Good morning, Q2B. Good evening here from the Airbus headquarters in Toulouse, France. It's a great pleasure to be addressing all of you today. Under typical circumstances, I would have looked forward to the opportunity to not only travel to San Jose, but meet in person, come together in one room, and explore how quantum technology can help solve key questions facing industries and society today. But these days, we find ourselves sitting physically distant from one another, scattered across the globe, staying home instead of flying, and adapting to a new normal. In the aerospace industry, we are seeing the dire repercussions of this new normal manifest themselves in the form of a global standstill in air traffic. Naturally, this implies a temporary interruption of the world's most rapid transport network, which affects tourism, trade, economic growth. Nevertheless, we at Airbus are firmly convinced that green recovery is non-negotiable. But we cannot enable a green recovery, much less a recovery at all, by working in isolation. We need to pull many levers to get there. This means connecting experts from different fields to exchange expertise and learn from each other. Continuing with data and intelligent gathering. Exploring multiple technology pathways, such as alternative fuels, electric hybrid electric propulsion, and smart materials that react to environmental conditions, and drawing upon groundbreaking fields like artificial intelligence and quantum computing, the latter of which brings us here today. In my early years in the aerospace industry, I would hear seasoned engineers say an airplane is 10,000 mechanical parts flying in close formation. Well, today airplanes have not only thousands of mechanical parts, but up to 250,000 sensors too. Indeed, aerospace has gone from a nuts and bolts business to one of the most data-rich and data-dependent industries in the world. And since it's getting more complex every day, we are seeing the physical limit of classical computer chip transistors. So you can understand why we're looking to unlock the data potential by going beyond today's standard high-performance computing platforms and further explore the promise awarded by QC. At Airbus, we see quantum technologies as a game changer for aviation. This is because in our line of business, we're constantly faced with situations in which we need to deal with multiple variables, especially when it comes to our great challenge of optimizing air traffic. To name just a few, fluctuating speeds, varying heights, and countless flight routes, which, by the way, also may vary due to weather conditions, wind streams, or even regional fuel prices, presenting us with an entirely new dimension of sub-variables, if you will. And since quantum computers are especially useful in the field of complex optimization, you can understand why we see a lot of promise in their applications. At Airbus, we were early adopters of quantum because we believe it will forever enhance the performance of our products and services, alter the way aircraft are built and flown, and help us solve the most complex challenges aerospace has to offer. But we believe the most powerful approach is that which is collective, inclusive, and broad. This is why we've called upon the QC community across the world to develop QC-based solutions to 5 flight physics problems, optimizing aircraft climb, fluid mechanics, aerodynamics, wing box design, and aircraft loading. But my colleague, Mark Fisher, will deep dive on that in just a few moments. What sets our challenge apart is that it facilitates a route for large industrials like ourselves to engage and explore quantum. and the level of engagement we have seen and the quality of the proposals we received, in my view, speak to the success of our approach. We are exceptionally proud that over 1,000 individuals hailing from more than 70 countries submitted proposals to the Airbus Quantum Computing Challenge, of which one winner will be announced shortly. But before we do, I'd like to ask Mark, our Head of Flight Physics and Senior Vice President of Engineering at Airbus, to please take you through why we believe QC will revolutionize our approach to flight physics and how we launched our challenge. Over to you, Mark.
Thanks a lot, Grazia. A very warm welcome also from my side. I'm very happy to be back at Q2B, even if we can only meet virtually this year due to the pandemic. Flight physics is the broad denomination of all scientific and engineering aspects related to the flight of an aircraft. It encompasses a broad range of disciplines from overall aircraft design, including aerodynamics, loads and air elasticity, mass properties, weight management, aircraft performance, and handling qualities. The future of aircraft design is very much dependent on finding ways of exploring new ways of optimization and multidisciplinary optimization in particular. It is about new technologies and how they contribute to improve aircraft design and performance. The data and physics that govern the analysis of such technologies are complex and computationally demanding, particularly as many of the associated parameters are correlated across a framework of multidisciplinary models or models of models. Addressing such complex systems of systems requires altogether new capabilities and more powerful computational means for design space exploration and MBSE-enabled MDO. With classical computers gradually approaching their limit, quantum computing could potentially offer a real breakthrough. Admittedly, the translation of our simulation and design problems into a quantum logic is non-trivial and might not even be feasible in every respect. As such, we believe that for some problems, full quantum solutions might be of interest, others are more likely to require a hybrid approach utilizing both quantum and classical computing capabilities. Often I'm being asked the question, why did you launch the Airbus Quantum Computing Challenge? First of all, we recognize that quantum computing expertise is not our core competency. However, we are very much interested and keen to gain an understanding of the maturity of quantum computing and how it can be used to address aerospace-specific challenges, bringing science out of the lab into our aeronautical industry. Furthermore, we want to be part of this journey and stay true to our Airbus values in pioneering innovation. We are keen to understand which hardware is optimal for different types of problem statements. Therefore, as an end-to-end user, you could say that we remain hardware agnostic with a focus on which combination of approach and hardware provides the best solution for different problems at hand. The problem statements for this quantum computing challenge were written with a balance between realistic and practical aerospace computational challenges in mind. We have deliberately chosen problems of different natures, some of which could actually be even solved with conventional computational means. The point was to explore how problems of varying complexity would potentially translate into a quantum logic and benefit from quantum computing. As a recap, the 5 problem statements were: problem statement number 1, which focused primarily on aircraft climb optimization. An aircraft follows several flight phases during its trajectory from takeoff to landing. Cruise is the longest segment and is considered most important from a fuel and time optimization perspective. Yet for the ever-increasing volume of short-haul flights, climb and descent are more critical. Fuel optimization during these segments is very valuable for airlines. The challenge focused on the climb and how quantum computing can be applied to arrive at a low-cost index, which is central to climb efficiency. Problem statement number 2 featured computational fluid dynamics. The efficiency of aircraft design relies heavily on the aircraft's overall aerodynamic shape. The design is performed using computational fluid dynamics, so-called CFD, which is a both resource and very time-consuming task. This problem statement aims to show how established CFD simulations can be run using a quantum computer algorithm, or alternatively be done in a hybrid way, combining quantum computing with classical computing means. There were two objectives to this problem: finding a faster way to solve the problems and assessing how the algorithm scales in line with the problem complexity. Problem statement number 3 is about quantum neural networks for solving partial differential equations. Solving differential equations, PDEs, is a major challenge when solving aerodynamic problems. Today, their resolution requires complex numerical schemes and high computational costs. Traditionally, PDEs were solved in a deterministic manner using numerical methods. Recently, neural networks, deep learning-based algorithms, have been deployed to solve coupled PDEs. These networks compute the time and space derivatives of a PDE, and the proposed challenge is to augment this new approach for aerodynamic problems with quantum capabilities. Problem statement 4 looked at wingbox design optimization. Given the limitations of classical computing, the aerospace industry faces a challenge in optimizing multidisciplinary design, which is when design configurations such as airframe loads, mass modeling, and structural analysis must be simultaneously calculated. Quantum computing offers an alternative path to explore a wider design space by evaluating different parameters simultaneously, preserving structural integrity while optimizing weight. This balance is particularly important in aircraft wingbox design, where weight optimization is key in order to reduce operating costs and environmental impact. And last but not least, problem statement number 5 featured aircraft loading optimization. Airlines try to make best use of an aircraft's payload capability to maximize revenue, optimize fuel burn, and lower overall operating costs. Their scope for optimization is limited by the aircraft's operational envelope, which is determined by each mission's maximum payload capacity, the aircraft's center of gravity, and its fuselage shear limits. The objective of this challenge was to calculate the optimal aircraft configuration under coupled operational constraints. As mentioned by Grazia, we are really excited by the interest the AQCC has generated and the number of excellent submissions. After an exciting journey since the launch of the challenge some time ago and the announcement of the 5 finalists in October, we have now reached an important milestone in the challenge that will help us to shape our future computing landscape. And now it's time to go back to Grazia for the announcement of the AQCC winners.
Thank you, Mark. Before we announce the winning team, I'd really like to express my personal gratitude and admiration for all teams who participated in our challenge this year. If you consider that only 2 years ago, the New York Times estimated that only 1,000 researchers can claim to understand quantum computing, well, we all have a lot to be proud when we consider the progress that has been made. Much of this progress is due to those of you who participated in our challenge, but also all of you in the quantum community who are tuning in today. And with that, I'm excited to announce the winning team of the Airbus Quantum Computing Challenge. Giovanni and Nicola from Machine Learning Reply, my deepest congratulations. Complimenti ragazzi, ottimo lavoro. Of the 5 problem statements put forward in our challenge, Machine Learning Reply addressed aircraft loading optimization. They were selected based on their high-quality submission and detailed approach, which used a quadratic unconstrained binary optimization algorithm to find optimal loading for an airplane, a very challenging task for classical algorithms these days. As Mark alluded to earlier, the loadability of an aircraft is a type of combinational optimization problem. Our challenge lies in the fact that the exploration of the full optimization space and the subsequent decision task is computationally very expensive. The work done by machine learning reply further proves how QC is an attractive solution to this loading task and other similarly challenging optimization problems, and a much more extensive and rapid one at that. We look forward to exploring the entire span of these solutions and more through what is bound to be a fruitful collaboration with our winning team. And now, a word from our winners.
First of all, thank you, Grazia, thank you, Mark, but also thank you to Airbus for this selection as winning team, but also for this international competition, because I really think it was a great idea. Our company, Reply, is a consultancy firm, and we want to stay ahead of the curve when it comes to technology and innovation. In fact, we have been working on quantum for the past 3 years, and when we saw your challenge, we just took it. The big question that everyone has in this field is, how do we map business problem to quantum computers? Of course, it's not an easy process, but being a consultancy firm and working in strict collaboration with business, that's what we're good at doing. But I also want to talk about the creativity of this process, because it's not only about technological mastery. For some new problems, you can't just open a book and read how to do it. For example, in the loading optimization problem, the difficult part were the constraints, because we had to respect constraints regarding the center of gravity or the distribution of the weights. And we had to find some new mathematical tricks to map all these different constraints into the same quantum computing model. But that was also the most fascinating part of this process, because at its core, it was about innovation, which is the combination of creativity and technology. And it's great to see companies like Airbus that are investing in innovation. We are very happy and proud of this result. It really gives value to the work that we have been doing. And one personal thing I want to add is that for me, being here today is amazing, because 3 years ago, I knew very little about quantum, but I was studying and reading quantum computing books of the same professor that are speaking at this conference in these days. So looking back, it really feels like an amazing journey. And the cool thing is that we are just getting started, because of course we are looking forward for this collaboration in 2021. And I think it will be an amazing opportunity. So thank you again so much. I give it back to you, Grazia and Mark.
Well done, machine learning reply. We are excited to embark on this collaboration with our aerospace experts. In the next year, together, we will have the opportunity to further explore the implementation of your approach, working with more relevant and specific data and exploring routes of business implementation. Thank you for your enthusiasm and effort put into your submission. I'd like to also extend my thanks to both the quantum computing experts and aerospace experts who have comprehensively evaluated all the proposals, and of course to QC for the help in shaping the problem statements. Together, we have made this challenge a real success, and we can all be very proud of this. Thank you very much.
Dear colleagues, seeing the exceptional work done by innovators like those awarded today gives me great optimism for the future. It justifies to some extent what we have always known to be true. The intersection of bold ideas, bright minds, and seemingly insurmountable challenges is the sweet spot of innovation. This is where breakthroughs happen, and it is a complete toolkit to improving and accelerating our processes far beyond anything we could have ever imagined. And looking at our world today, channeling this open and collective approach and continuing to make these intersections happen is more important than ever before. On behalf of Airbus, thank you so much for having us today. Until next time.